Moynahan. I'm a professor in the history program and the co-director of the science, technology, and society program at Bard. So for these reasons, a particular pleasure to introduce Professor Naomi Oreskes, professor in the Department of History and Program of Science Studies at University of San Diego, and also adjunct professor of geosciences there. It seems particularly valuable to have her at this conference because her own work, and particularly the work she'll be talking about today, is so focused on Arendt's idea of truth in politics, and really combines a sort of ethical, intellectual, and scholarly rigor in a way that I think does Arendt proud and is particularly interesting in the context of this conference, and indeed, particularly in terms of the central issue of this conference, which Roger has sort of had focus on the essay by Arendt on truth in politics, just because she really sort of leads us to a new understanding of the politics of how fact and institutions fit together. And I think she's going to describe this at greater length, so I won't try to steal any of her thunder. But essentially what Arendt describes as the new role of gigantic interest organizations in the creation and distribution of fact is something that her work really carries forward directly. In this regard, her own training is important. She was originally trained as a scientist, as a geologist, at the University of London, Royal School of Mines. She worked for 3 years as a geologist in Australia before switching to the history of science, graduating in the special program in geological research and history of science at Stanford University, where she worked particularly on continental drift theory, which was the subject of her 1999 book, The Rejection of Continental Drift, Theory and Method in American Earth Science, and Plate Tectonics, An Insider's History of the Modern Theory of the Earth in 2003. This is important for what she's going to be talking about today because plate tectonics was itself, of course, originally an extremely controversial theory. In the 1940s, there were no less, as she notes, than 19 other explanations of how global movement of geological strata occurs than what we now know as plate tectonics. And with this, her work really came to focus on consensus and dissent in science. How and what do we decide is truth and reality within science? Is it simply mathematical transcription? Is it a direct relation to reality? And if it's not such a thing, what is it precisely? When we see a bird die in a vacuum, is the evidence we have for that juridical, like the way a jury decides on evidence? Is it based on some other standard of truth? How do we establish such consensus? And tectonics became an area where she could look at this. This became focused in particular on the issue of institutions, which her work really highlights in a way. To some extent, I think the popular reception of history of science in the 70s and 80s sort of picked up on Thomas Kuhn, and everybody was interested in who's causing a paradigm change, who are the leading people who are contesting scientific truths. And her work really emphasizes how do we get to a normative science, and what does that mean? And particularly as we start to turn to new politics relating to climate change, what does that mean? And how do we start to defend ideas of normative science? In particular, in her widely hailed book, Merchants of Doubt, How a Handful of Scientists Obscured the Truth on Issues from Tobacco Smoke to Global Warming, which you can see up there, which she wrote with Eric Conway, she really sort of had to address this question on an entirely new level. Sort of what happens when ideas of scientific truth meet up with the rationality of the giant organizations that Arendt talked about with public relations in its new and modern forms. How was it that even though climate theory change, anthropogenetic climate change was recognized quite widely by 1992, by 2002, by 2005, why was nothing happening? What was it that was slowing down public awareness of this problem? And really what she discovered here, in combination with other researchers, is that this was really to a remarkable level of actual process that had been initiated through a sort of real scientific research, funded to obscure what institutions had arrived at as consensus, and this had started particularly with the tobacco industry. Something somewhat ironic, we don't have the iconic image of Hannah Arendt up anymore, but somewhat ironic in terms of Arendt's famous perpetual smoking. But you know, what does it mean to smoke and choose that as a risk when the risks aren't actually clear to you? You know, it's one thing to go on a roller coaster that's rickety. It's another thing to find out that it was actually inspected and the inspection proved that it wasn't safe, right? And there's a way in which what had come to pass is an obscuring of the basic fact of the link between tobacco and lung cancer in particular that was already recognized by 1964 quite broadly, but the tobacco industry realized they could fund legitimate scientific research of alternate explanations, and that this research could sort of slow down the process of public recognition of this. And this was really sort of, I think, the genius of this insight is to recognize this was using different forms of how truth exists in different fields. Right? In science, as she emphasizes, this occurs through institutions. Institutions develop expert knowledge through which people who are experts on a field decide, essentially in a juridical manner, what Ludwig Fleck described as sort of a curious democratic manner, but within a certain group, what counts as truth. National scientific foundations, all of which in the world have decided, for instance, that global climate change is real. That counts as something. In a court of law, however, any expert witness can stand up and represent a field. And that knowledge can be used to slow down legal processes. And in journalism, as we know, usually the standard of truth is to take one side against another, and that can often be used to have one side represented as real as the other, even though in a scientific community it would be considered not real at all. And her work really sort of develops this link between how these different forms of truth appear in different fields, and I think that's its value. I would recommend the book, among other things. You gradually realize it's a murder mystery, right? I mean, something has been done, it's a whodunit. And it's a whodunit in which nobody initially recognizes that it's a murder mystery. And that's sort of part of the power of the book. And in this way, I think it really sort of fits into what Arendt describes as sort of the storyteller value of politics. You know, by hearing this story, and as was mentioned in the last talk, you get a sort of pattern recognition. Aha, this happened with the tobacco industry, this happened with ozone, this happened with strategic defense, the same thing's happening with global warming. The science is not a lie. These are real scientific studies being done, but often to obscure what's already the real consensus within a certain field. And I think this is really sort of the brilliance of the book, and for that reason it's a delight to introduce Professor Naomi Oreskes.
Well, thank you for that kind introduction. It's a pleasure to be here, and it has not escaped my notice the irony of the fact that Hannah Arendt was a heavy smoker. But as you said, people are entitled to smoke if they want to, so long as they know the truth about it. That's my view. I also, though, I wish I had realized ahead of time that this was a murder mystery, because I could have gotten a much better advance. So in Truth and Politics, the article that we've already heard about quite a bit today, Hannah Arendt drew on Leibniz's distinction between factual truth and rational truth. Rational truth in science or mathematics, she suggests, is rather safer from political attack than factual truth. She writes, if we think now of factual truth of such modest verities as the role played in the Russian Revolution of a man by the name of Trotsky, who appears in none of the Soviet Russian history books, we at once become aware of how much more vulnerable they are than all the kinds of rational truth taken together. Dominion, to use Hobbes's language, when it attacks rational truth, oversteps, as it were, its domain. Facts and events are infinitely more fragile things than axioms, discoveries, and theories. Well, I have to say that to the extent that Arendt might have been correct in 1967, then we may conclude that the world has surely changed, that something new emerged in the second half of the 20th century, the organized rejection by power of rational truths. We find today that our rational truths are highly fragile, and that Dominion considers it well within its domain to deny, reject, and attack not only those truths themselves, but also those who deliver them to us. Arendt also notes that a hallmark of the rejection of truth is that, quote, to the extent that unwelcome factual truths are tolerated in free countries, they are often, consciously or unconsciously, transformed into opinions. I kind of got the chills when I read that, because I think that's exactly right for the cases that my colleague Eric Conway and I have been studying. On the subject of climate change caused by human activities, we're all familiar with Vice President Al Gore's popularization of the notion of an inconvenient truth. But many of us have not realized the extent to which that scientific facts have indeed been transformed into matters of public opinion. The facts of climate change are now the subject of repeated public opinion polls, and often the questions in these polls are framed of questions of what the respondents thought, believed, or perceived to be the case. So one clearest example of this was an ABC News poll back in 2006, but there are many, many other examples in which nearly 2/3 of respondents perceived a lot of disagreement among scientists on the question of anthropogenic climate change. Only 1/3 thought that scientists agree that climate change is underway, and only 1/3 believed that the rise in world temperatures is mainly caused by things people do, all of which are at odds with the factual evidence. Now, I'd like to begin my story today in Texas, because it's currently suffering one of the worst droughts in recorded history, a drought that may rival the Dust Bowl and may, in the fullness of time, alter Texas and American history. But it's not just drought. Texas is one of the U.S. states most at risk from sea level rise, hurricanes, increased storm surge, coastal erosion, flooding, and other consequences of climate change. Many of us remember Hurricane Rita, highly frightening to anybody who knows anything about hurricanes, because the scale, the size of this hurricane is just unbelievable. This was a hurricane nearly as big as the entire Gulf of Mexico. But the most frightening image from Hurricane Rita, I would argue, was not the one I just showed you, but rather this. This image of wealthy people, mostly white people, with automobiles, with gasoline in their tanks, stuck on the freeway trying to escape from Houston, and no one had the political authority to order those other lanes of traffic to be opened to traffic leaving Houston. Now, currently, Governor Rick Perry of Texas, who aspires to be the President of the United States, has publicly rejected the scientific facts regarding climate change and its impacts, and has openly accused professional scientists of fraudulent behavior. But what I'd like to start with then here is not the current state of affairs in Texas, but with a different Texan, our former president, President George H.W. Bush. One of the problems with Americans, as Adlai Stevenson once said, is that we haven't read the minutes of the previous meeting. So I want to take you back to the minutes of an important meeting which most of us seem to have forgotten, and that was the Earth Summit in Rio de Janeiro in 1992, when President George H.W. Bush signed the UN Framework Convention on Climate Change, which committed the United States and 192 other signatories to taking action to preventing dangerous anthropogenic interference in the climate system. And when President Bush signed the Framework Convention, he called on world leaders to translate the written document into concrete action to protect the planet. So what happened? What happened since 1992, and why didn't we take those concrete steps that President Bush promised us? So what I'd like to do today is to tell you a story about the evolution of climate science and the emergence of a scientific consensus about rational facts, but at the same time also a story of the emergence of a political challenge to those rational facts, a story of selling uncertainty and emphasizing doubt for political reasons. And then finally, at the end, because this is a real feel-down talk, to end on what I hope might be at least a slightly positive note, to suggest how we might begin to move past doubt to address the dual problems of finding the energy we need while protecting the environment upon which we depend. So the scientific story begins more than 150 years ago with this man, John Tyndall, who first established what it meant for something to be a greenhouse gas. That is to say that certain gases, most notably carbon dioxide and water vapor, have the distinctive property of being highly transparent to visible light, but rather opaque to infrared radiation or heat. So light from the sun comes into the Earth's atmosphere and is trapped and held in by these greenhouse gases. Now, Tyndall recognized that this was largely a good thing, because without greenhouse gases, the Earth would be as cold as the moon and quite inhospitable for life. But in the 1900s, Svante Arrhenius realized that you can always have too much of a good thing. He was the first to suggest that by burning fossil fuels, mainly coal, we were releasing carbon dioxide to the atmosphere, where it could increase in quantity and begin to warm the Earth. Arrhenius did the first calculations of the effect of doubling carbon dioxide in the atmosphere and concluded that the planet would warm between 1.5 and 4.5 degrees Celsius, so as much as 9 to 10 degrees Fahrenheit. Now, he was Swedish, so he thought global warming would be a good thing. Today, I'm thinking the same thing here myself. The first empirical evidence that warming might actually already be underway was compiled in the 1930s by Guy Stewart Callendar, a British steam engineer. Now, there was one important technical uncertainty at this time, and that had to do with the competing effect of water vapor. So as I said, Tyndall recognized that water vapor is a greenhouse gas as well as carbon dioxide, and some scientists thought that given the amount of water vapor in the atmosphere, much more than carbon dioxide, that it was very unlikely that small increases in CO2 could have any significant effect. Well, this question was answered by the spectroscopist Gilbert Plass in the 1950s, one of the first people to use satellite data to analyze the upper atmosphere. And he showed that, in fact, the absorption bands, the heat absorption bands of water vapor did not, in fact, overlap with those from carbon dioxide. So if you increase carbon dioxide, you would, in fact, increase the warming of the atmosphere. Plass's work was crucial to the work of someone you may have heard of, Roger Revelle, who was the teacher and mentor to Al Gore. In 1957, Roger Revelle, with his colleagues Hans Suess, published an article in a scientific journal in which they pointed out that mankind was performing a great geophysical experiment. By returning to the atmosphere in less than a century, carbon dioxide that had been stored in fossil fuels over the course of hundreds of millions of years of geological time. And they argued, as part of the International Geophysical Year, that scientists should begin to measure the amount of carbon dioxide in order to monitor what effect, if any, it was having on the Earth's climate. That monitoring, the CO2 inventory, became the life's work of Charles David Keeling, who began the systematic measurement of CO2 in 1958 as part of the International Geophysical Year. By the early 1960s, after just a few years, Keeling had concluded that his own data showed that there was, in fact, a small but detectable increase from about 312 parts per million when he first began to measure it to about 315 by 1965. Now, this doesn't sound like a big number, but the fact that he could detect it at all and in such a short period of time, not a century or half a century, but just 3 years, convinced him, Revelle, and many others that this could potentially, in the fullness of time, become a significant problem. So in 1965, as part of the President's Science Advisory Committee, Roger Revelle and Keeling wrote, "By the year 2000, there will be about 25% more CO2 in our atmosphere than at present, and this will modify the heat balance of the atmosphere to such an extent that marked changes in climate could occur." Now, we often lament that politicians don't listen to scientists, but at least one did. In a special message to Congress in 1965, President Lyndon Johnson said, this generation has altered the composition of the atmosphere on a global scale through a steady increase in the burning of fossil fuels." Now, in 1965, President Johnson had a few other things to worry about. War in Vietnam wasn't going so well. Civil rights workers were being murdered. And not very much serious interest was generated about the question at that time. But that began to change in the 1970s with the rise of computer models. Scientists began to develop the first complex numerical simulation models that could model the atmosphere as a system and to revisit the calendar question, the Arrhenius question, the Tyndall question of what would happen if we doubled the amount of CO2 in the atmosphere. And with mathematics that were much more sophisticated than what Callendar and Arrhenius had had 70 to 50 years before, they essentially came to the same conclusion. And this then began to lead to serious discussion of its implication in policy circles. And in the mid to late 1970s, a whole series of reports were written in Washington, D.C. and elsewhere discussing what the social, economic, and political consequences of a warmer world would be. In 1979, the U.S. National Academy of Sciences summarized these reports by saying, quote, "A plethora of studies from diverse sources indicates a consensus that climate changes will result from man's combustion of fossil fuels and changes in land use." So what we see here is that already in 1979, there was a scientific consensus about a prediction, about an expectation. The expectation that given the increase in carbon dioxide that Dave Keeling had measured, that global warming would occur. There was also a consensus that it was not trivial. It was not a small concern. And so the Academy continued, "The close linkage between man's welfare and the climatic regime within which his society has evolved suggests that such climatic changes would have profound impacts on human society." So we had a consensus about what was expected to happen. We had a consensus that it was not trivial. But what we did not yet have a consensus about was when. Most scientists at that time thought that changes would not be detectable until the 21st century. In fact, one of the scientists I interviewed told a story of how he went to the Carter White House to present one of these reports, and one of the staffers at the White House asked, well, when is all of this going to happen? And one of the scientists said, well, maybe 40 years, and the staffer says, please come back in 39. So scientists were surprised when only 6 years later, NASA climate modeler Jim Hansen and his team concluded that anthropogenic climate change was already underway. They published this result in leading peer-reviewed journals, and Hansen testified to this effect in Congress in 1988, declaring that he was now 99% certain that climate change caused by human activities, not the sun and not natural variation, but human activities, had now become detectable. And it was this emerging and disturbing evidence that had led in part to the creation of the Intergovernmental Panel on Climate Change, also in 1988. But it also led to something else, to the emergence of a politically motivated campaign to cast doubt upon that science, to challenge the rational facts. This campaign focused on a counterclaim that the science was not settled, and therefore it would be premature for governments to take action. And the origins of this claim can be traced back to a small handful of people. Now, I don't usually feel compelled to make this disclaimer, but given the previous talk, I do feel compelled to say this is not a conspiracy theory, but it is a story that begins with a small handful of men. Every story has to start somewhere. So today, as many of you know, doubt about climate science is promoted in many quarters. But one of the most important for the past 2 decades is the George C. Marshall Institute, a think tank in Washington, D.C. For more than 2 decades, they have denied the reality of global warming or insisted that if there is warming, it is not caused by human activities. So where did the Marshall Institute come from? How have they promoted doubt about climate science, and why? Well, here are your 3 men. The 3 founders of the Marshall Institute were all physicists who had come to positions of power and influence, and in some cases nearly fame, during the Cold War, working on Cold War weapons and rocketry programs. On the left, Robert Jastrow, the founder of the Institute, who was an astrophysicist and the head of the Goddard Institute for Space Studies at NASA, where he had worked extensively on the Apollo program. On the right, William Nirenberg, a nuclear physicist who had worked on the Manhattan Project and then became the longtime director of the Scripps Institution of Oceanography, where I now work, where he directed a large number of different projects, mostly Navy-funded projects on submarine acoustic detection during the Cold War. And in the center, the original chairman of the board of the Marshall Institute, Frederick Seitz, a solid-state physicist who had worked on the hydrogen bomb and had risen to influence as president of the National Academy of Sciences and president of the Rockefeller University. Now, these men had known each other for many years, serving on various advisory panels to the U.S. government, the U.S. military. They had also worked as consultants to the private sector. And in the early 1980s, they found themselves working together on an advisory panel to the Reagan administration on the question of strategic defense, or what most of us remember as Star Wars, the real thing, not the movie. In 1984, they created the Marshall Institute to defend strategic defense against scientists' opposition and to promote the continued importance of science and technology in national defense, in part by insisting on the reality of Soviet strength, of a kind of overwhelming Soviet strength, and raising frightening claims about U.S. weakness. I don't have time to talk about this in detail, but there's a whole chapter in the book where we talk about this whole argument. I'll just show you one example of the kind of things they did. They wrote lots of articles, letters to editors, opinion pieces. My favorite one is this one, America has 5 years left, 1987. Now, at the same time, Frederick Seitz had retired from the Rockefeller University and had taken on one last job working as a consultant to the R.J. Reynolds Corporation. So this is where tobacco joins our story. Now, as many of you know, and has been written about by historians like Robert Proctor and Alan Brandt, one of the principal strategies of the tobacco industry, really the principal strategy, to defend tobacco against the threat of government tobacco control was doubt-mongering, to insist that the science around tobacco was not settled, and therefore it would be premature or even inappropriate for the government to act to control tobacco use. In 1989, these 2 stories came together. The Cold War ended rather abruptly, much more abruptly than most people expected. The Berlin Wall came down, the Soviet Union began to break apart. So you might have thought that these men who had dedicated their lives to fighting the Cold War would have been happy, would have been satisfied that their own goal of the defeat of the Soviet Union had in fact been achieved. But they weren't content. Rather, they found a new enemy. And that new enemy was what they considered to be environmental extremism, what they thought was the exaggeration of environmental threats by people with a left-wing agenda. And they applied the tobacco strategy that Seitz had learned working with R.J. Reynolds to insist that the science was unsettled. Doubt is our product, ran the infamous memo written by one tobacco industry executive in 1969, since it is the best means of competing with the body of fact that exists in the minds of the general public. And by the way, somebody asked about how do you recognize a real conspiracy when it happens? This memorandum became one of the pieces of evidence brought by the U.S. Department of Justice when the tobacco industry was indicted for criminal conspiracy to defraud the American people. So an indictment by the U.S. Department of Justice is one thing you could look for. Now, one of the things that the tobacco industry realized, though, going back to the 1960s, was that for doubt to be credible, they needed experts to supply it. If tobacco industry executives stood up in public and said, well, we're not sure about that science, most of us wouldn't find that credible. But if a scientist said it, if a distinguished scientist said it, if a former president of the National Academy of Sciences said it, well, that was a very different matter. The public would receive it differently, and in particular the media, who we've heard a lot about today, would also treat it rather differently. And the media is a big part of this story, which again I don't really have time to talk about here, but we discuss at some points in the book. So they needed scientists, they needed credible experts to supply the doubt. And this is the story we tell in the book, the story of scientists supplying doubt. But not just about tobacco. On a whole set of issues over the course of the better part of 3 decades, beginning with tobacco, but running through the question of nuclear winter, acid rain, stratospheric ozone depletion, the human causes of global warming, and most recently, going on even today, a revisionist attack on Rachel Carson and the science around the hazards of DDT. So how did they do it? How did they supply doubt? Well, to answer that question, you'll have to read the book, which unfortunately is not on sale here, but you can buy at Amazon. I have to pay college tuition for my children. But I want to say a little something about it here today because it's so relevant to our question, to Hannah Arendt's question about how factual facts, rational facts, facts about history or science get destabilized. So there were many different strategies. We talk about them at length in the book. But one of the strategies that I thought was particularly relevant to talk about here today was that they made claims that were directly at odds with established scientific conclusions, directly at odds with what Arendt would have called the rational facts. So I want to give you 4 examples of these kinds of counterfactual claims. So one claim that many of you may have heard, it's continuing today, is the claim that the warming has stopped. Well, this claim is completely false. This is a recently released chart of a new study comparing the historic temperature data done by a group of previously skeptical scientists at Berkeley. That's another long story, but comparing their data to 3 major existing analyses of the temperature records from NASA, NOAA, the National Oceanic and Atmospheric Agency, so 2 different American U.S. government agencies, and HADCRU is the Hadley Center in the United Kingdom. And as you can see, there has been a variable but steadily increasing temperature record since the Industrial Revolution, but in particular, what scientists have focused on is this very steady and very sharp uptick in the temperature record since about, well, roughly the last 50 years, which is also the period of the radical increase in our burning of oil and gas. So just to say, so the claim that the warming has stopped is just simply flat out false. A second claim that's often made, and again, this one is still repeated today, it's all over the internet, and I agree with what Jonathan Kay said about the role of the blogosphere, is that warming is caused by the sun. One blogosphere version plays off James Carville and says, it's the sun, stupid, right? And this is something that intuitively appeals to many of us because we know that the sun is warm, right? So this is, right. So intuitions are not always right. This is one thing that's tough about science, is it makes you realize that your intuitions about things can be incorrect. So this is an example we talk about in the book because it's a particularly egregious one. So in an early report on climate change, the Marshall Institute scientists published this graph, which they said showed, look, here's the actual the actual observation of increased temperature. Here's what you'd expect based on the climate models if it's being driven by the greenhouse gas effect. And look at this gigantic gap between the observation and the theory. So obviously it can't be caused by carbon dioxide, therefore it must be the sun. Well, this is a classic example of taking data out of context, because this chart is actually this chart taken out of this much larger and rather more complicated scientific argument. What the argument on the right actually says, and this is from James Hansen and his team, is that actually no one driving force can explain the observed temperature records. That if you take the observed records and you analyze it only in terms of carbon dioxide, or only the sun, or only volcanoes, which are the three major drivers, none of them explain the observations. But if you put all of them together, then indeed you can rather closely match the historic records. So the observed warming is a combination of changes in solar radiation, cooling by volcanic dust, and warming by greenhouse gases. A third claim that's frequently made is that there's no consensus among experts. This is my favorite claim because I'm the one who refuted it. So here we have a recent book by Patrick Michaels, who works for the Cato Institute, Shattered Consensus, the True State of Global Warming. Here's my paper published 8 years before, which analyzes the scientific literature and shows that indeed there is a consensus among all relevant publishing experts. And then this is actually my favorite one, because it's so obscure that it's gorgeous. This is the claim often made by Richard Lindzen at MIT that the CO2 effect is swamped by water vapor. Again, another one that feels intuitively right. How can just a few parts per million of carbon dioxide swamp this huge effect of the much greater quantity of water in the atmosphere? Well, you may have wondered why a few minutes ago I insisted on putting in this rather obscure graph by Gilbert Plass. This is why, because this argument, which is all over the internet, was proved to be incorrect 60 years ago. So one of the things they do is resurrect. Sometimes it's said that conservatives don't believe in recycling, but they do. They recycle refuted arguments. Take an old argument that nobody remembers anymore, nobody even knows who Gilbert Plass was, resurrect it, pretend that it's a refutation of the existing science, when in fact it's not. So every one of these claims are the opposite of what scientific evidence tells us. And probably for most of you in this audience, these claims do not generate a visceral reaction, but for climate scientists they do. Because for scientists, these are the scientific equivalent of claiming that Belgium invaded Germany. So why did they do this? We know why the Soviets expunged Trotsky from their history books. But why have Americans been in denial about climate change? Well, one of the great things about being a historian is that you often don't have to speculate, because if you dig in the archives deeply enough, you often find places where people answer the questions themselves. Now, obviously, there are many reasons. This is a very complicated political issue. There are many reasons that Americans are particularly in denial about climate change. But for the original merchants of doubt, for the place where this story begins, in the Marshall Institute and in the Cold War, the answer is to be found in its Cold War origins. And it was provided most clearly by a fourth physicist in our story, sadly also a man. I have nothing against men, but, there is a pattern here. A man by the name of S. Fred Singer, who was also a Cold War physicist. In fact, he was the proverbial rocket scientist, having worked on some of the earliest rocketry programs. And like the others, challenged the scientific evidence of acid rain, the ozone hole, and global warming, and tobacco. So in the early 1990s, Fred Singer worked with the Philip Morris Tobacco Company to attack the U.S. Environmental Protection Agency over the issue of secondhand smoke. In 1993, working with a man named Kent Jeffries, a lawyer for the Cato Institute, he published a report entitled EPA and the Science of Environmental Tobacco Smoke. And I'll talk more in a minute about the various different think tanks that become involved in the story. But the funding for this report came from the tobacco industry, but channeled through a seemingly independent institute, the Alexis de Tocqueville Institute. Now, why were they attacking the EPA? Well, the EPA had declared secondhand smoke to be a Class A or proven carcinogen. They concluded, based on review of was about 6,000 peer-reviewed scientific studies, that secondhand smoke was responsible for 3,000 excess cancer deaths in the United States every year, and between 150,000 and 300,000 cases of bronchitis and pneumonia in infants and small children. They also said that it was correlated with a risk in sudden infant death syndrome, a result which has now been confirmed by further studies. How many people here knew that secondhand smoke causes sudden infant death syndrome? It's a very interesting buried scientific fact, but it does. So this evidence was supported by diverse independent peer-reviewed studies. It was affirmed by the US Surgeon General. So why would a physicist challenge it? Well, Fred Singer answered that question. He wrote, "If we do not carefully delineate the government's role in regulating dangers, there's essentially no limit to how much government can ultimately control our lives." And indeed, throughout contrarian writings, we see an anxiety, a kind of Cold War anxiety, that environmentalists are socialists, using climate change as a lever to affect social or economic change. They refer to environmentalists as watermelons, green on the outside, red on the inside. George Will, writing for the Washington Post, has called environmentalism a green tree with red roots. And my favorite here, we get the real conspiracy theorists. Senator James Inhofe has threatened to indict climate scientists for conspiracy to lie to Congress and has accused me personally of being part of the liberal conspiracy to bring down global capitalism, to which I respond that liberals should be so organized. And of course, as part of this theory is that environmentalists have a hidden agenda, which is anti-business, anti-free market, and anti-technology. So, for example, Fred Singer also wrote, "And then there are probably those with hidden agendas of their own, not just to save the environment, but to change our economic system. Some of these coercive utopians are socialists, some are technology-hating Luddites. Most have a great desire to regulate on as large a scale as possible." And he continued, "More dangerous of all are those who have a hidden political agenda, most often oriented against business, the free market, and the capitalist system. After the collapse of socialism, it is no longer fashionable to argue for state ownership of industrial concerns. The alternative is to control private firms by regulating every step of every manufacturing process." And Frank Luntz, the Republican pollster and strategist, who wrote, "Once Republicans concede that greenhouse gases must be controlled, it will only be a matter of time before they end up endorsing more regulation." More recently, CBS News had a story in June of 2011 when the Republican presidential candidate Mitt Romney became the only Republican running for president at that time and breaking ranks with most of his party members, when he said he accepted that the scientific evidence that humans did contribute to global warming. His opponent, former House Speaker Newt Gingrich, said that the push to address climate change is simply the newest excuse by liberals to take control of our lives. So what we see here then, in a nutshell, is that these debates were not about the science. They were about governance, and more specifically about regulation. They were about how, or even whether, governments should intervene in the marketplace to protect health, human and environmental health, or to promote new technologies that might do so. The merchandising of doubt was not driven by epistemic concerns about the science, not by weaknesses or instabilities in the science, but by politics, by political commitments to laissez-faire economics, the belief in an inextricable link between free market capitalism and personal freedom, and a hostility to regulation. And also by fear. Fear that the mechanisms being proposed to limit climate change, whether a carbon tax or a cap-and-trade system, would also limit our personal freedoms. This was a fear that was born and nurtured in the Cold War, a fear based on the threat of Soviet expansionism, Soviet totalitarianism, but that lived on well past the times and circumstances that may once have justified them. A fear that lives on today, nurtured by individuals and institutions whose self-interests align with it. Because what we see today, then, is that although this story began with 3 men and 1 think tank, it has since grown in monumental proportions. Today, there is a complex network of free market think tanks and foundations, actually so many that I couldn't fit them all on one slide, but these are some of the most important ones, a whole network who challenge the scientific evidence of anthropogenic climate change. Some of them are very famous. You've heard of the Cato Institute and probably the Heartland Institute, Heritage Foundation, but also more obscure ones such as the Rio Grande Foundation and one that was very obscure until about a year ago, the Americans for Prosperity, who are no longer obscure because they are a major funder of the Tea Party. What these think tanks all have in common, in addition to doubt-mongering about climate change, is the promotion of laissez-faire economics, the promotion of free market solutions to social and environmental problems. George Soros has called this ideology free market fundamentalism, the belief that all wealth arises from free markets and that any attempt to intervene, even for a good cause, will end up being counterproductive. This faith in free markets is also tied to a faith in technology. It's linked as well to a philosophy known as cornucopianism developed by the economist Julian Simon. This is the view that was most clearly explained in his book, The Resourceful Earth, and here again we see the Cold War connection, the co-editor, Herman Kahn. The view that the greatest resource of all is human ingenuity, and that therefore all problems can be solved, and in a timely manner, by technological innovation fostered in free markets, so long as governments don't intervene in those free markets. And indeed, they go further to say that only free markets produce the technology we need. Well, what does history have to say about these claims? History has shown, I believe, that market economies are more efficient than centrally planned ones, and technology has enabled us to solve many important human problems. But history and science also tell us that there's an important limit to markets, an important problem with the free market fundamentalist and cornucopian views. And that is the problem that economists call external costs, or more jargonistically, negative externalities. That is to say, costs that accrue to people who did not reap the benefit of the activities that generated them, costs that are not reflected in the price, the market price of goods and services. If you open any Economics Textbook 101, you will find that environmental damage is the textbook case of a negative externality. And this is the common thread that unites the diverse science from tobacco to global warming challenged by the merchants of doubt. Every single one of these cases is a case of a market failure, of a large negative externality. And hence Nicholas Stern, the former chief economist of the World Bank, has recently called anthropogenic climate change the greatest and widest-ranging market failure ever seen. In fact, actually, there are two market failures. One is a price failure, that the price of fossil fuels does not reflect their true costs, and the other is an innovation failure, that the free market left to its own device has not provided us with the technological innovation we need, or at least not on a sufficient scale and not fast enough. And these issues, these market failures, which seem to suggest the need for government intervention, emerged historically just at the same moment that the Reagan administration was arguing for less government and less regulation, as advocated by the Chicago economist Milton Friedman, shown here shaking hands with the president, and who in the book we talk about his influence more. So this, we would argue, put the Reagan administration on a collision course with science. And hence the origins of this story, the beginning of the story in Star Wars and strategic defense, is not a coincidence. But it wasn't just the Reagan administration. I think it's extremely important for Democrats and liberals to realize that although this may have started in the Reagan administration, this is a story that implicates a very wide range of the American political spectrum and parts of Europe as well. Because throughout the 1990s, the same concept, the neoliberal idea of releasing the magic of the marketplace through deregulation, was promoted very broadly in what was called the Washington Consensus, promoted by Democratic President Bill Clinton and UK Labour leader Tony Blair, promoted as well by Alan Greenspan, the longtime chairman of the US Federal Reserve, who many people don't realize is an acolyte of Ayn Rand. Throughout the 1990s and 2000s, right up to the global fiscal financial crisis, there has been, throughout the United States and much of Europe, a bipartisan consensus on the virtues of deregulation and the value of releasing the so-called magic of the marketplace. Now, this is a perspective whose limits, I think, have become rather clearer in the past few years, but to the extent that Americans in general have tended to believe in the magic of the marketplace, we've all engaged in some degree of magical thinking, denying the facts and persuading ourselves that we are all entitled to our opinions on these matters. Now, some of you will have noticed that there are several ironies in this story. Perhaps the most important irony is that the energy sector is anything but a free market. The World Bank, working together with OPEC, the OECD, and the Institute for Energy Analysis, recently analyzed how much global subsidies, how many global subsidies there are to fossil fuel production and consumption globally. And the most recent year for which we have data, 2008, $700 billion in global subsidies to fossil fuel production and consumption. Now, how much was the Troubled Assets Recovery Program? $700 billion. So this is the equivalent of bailing out the fossil fuel industry every single year. I'm going to skip this. The important point for us to recognize here, though, is it's not just the energy sector. Energy is a heavily subsidized industry, both in the United States and elsewhere, but it's hardly unique. Market subsidies are everywhere, particularly in agriculture, corn, soybeans, tobacco, sugar, but also the interstate highway system, rural airports. We heard a lot about that last summer, the post office. And there are many things we don't allow people to buy and sell in the marketplace, among them human beings, heroin, body parts, votes, or at least not without a license. As a professor, I always find it kind of amazing that I can corrupt the minds of young people without a license, but I can't cut their toenails. The fact is that we routinely accept all kinds of diverse interventions in the marketplace where necessary to remedy market failures, level playing fields, prevent fraud, or protect the innocent and vulnerable. And again, I could have a much longer list, but it wouldn't fit in the slide. But here's just a short example of various market interventions through the course of history, including things like the Sherman Antitrust Act, Federal Deposit Insurance Corporation, Social Security. The important thing about these examples is that every single one of them, when first proposed, was opposed as an unfair restraint on trade or an unfair intervention in personal freedom or the free market. So the free market is a theoretical idealization. It's one which we routinely compromise when we consider it necessary or desirable to do so. So the real question facing us is not whether or not there's a role for governance to address market failures that have led to the dangerous anthropogenic interference in the climate system. The real question is how to address those failures and remedy them. And that's something that we cannot do if we are in denial about the fact that the failure has even occurred. So, as I mentioned, the denial of climate change has also been coupled with a kind of faith in technology. And so I wanted to just spend a few minutes now at the end of my talk talking a little bit about technological innovation and to try to leave you perhaps on a slightly more optimistic note. So in 1983, Ronald Reagan argued that technology will ultimately be the answer to the problems of providing energy and protecting the environment. And as a historian, you're always looking for things you agree with in people whom you otherwise don't agree with, right? You're always trying to understand where other people are coming from. And when I read this, I thought, oh, well, here's something that I agree with Ronald Reagan on. So I think that Reagan was correct about that. But the question that he didn't pose, that his administration didn't pose and neither did anyone else, was how do we get the technology we need and how do we get it in a timely way? And this is where I think ideology still continues to stand in our way, but the facts of history may perhaps guide us forward. Milton Friedman once insisted that the great advances of civilization in industry or agriculture have never come from centralized government. The cornucopians argued this as well, arguing that only free markets produce the innovation and technical change that societies need. Well, this is simply untrue. We know that Hannah Arendt was highly concerned with the injustices of the Soviet Union, but whatever else the Soviet Union was or wasn't, it was a technologically innovative society. The Soviets put a satellite in space, they put a man in space, in fact, they put a woman in space well before Americans or Europeans did. The problem with the Soviet Union was not that they lacked technological innovation. The problem was that the benefits of technological innovation did not flow to their people. And in fact, if we look at the history of technological innovation in the United States, we find that many of the most important technological innovations of the 19th and 20th century were the result of public-private partnerships. And again, I don't have time to go into all of these in detail, but in a few years, hopefully Eric Conway and I will have another book on this topic. So the idea that technological innovation is only fostered or even best fostered by the private sector left to its own devices is not supported by the facts of the history of technology. So to conclude, climate change is a market failure. But it's a failure that can be remedied by putting a price on carbon, by government investment in energy and energy infrastructure, and in creating incentives for the private sector to invest in non-carbon-based energy sources. The government already intervenes in energy and other markets in myriad ways, many of which, not all of which are beneficial, but many of which are. So the issue is not whether or not we intervene in the market, but how we intervene, what interventions make sense, and to judge that, we have to take into account what we know from science. Because we ignore the facts of nature at our peril, and denying them does not make them go away. And as the novelist Kim Stanley Robinson has pointed out, the invisible hand never picks up the check. Thank you very much.
Thank you again for that lovely talk that actually covered a good deal more than the book, but also suggested a lot that's in the book in more detail. I guess the immediate question I had, and I sort of brought it up in my introductory remarks, has to do with education and pedagogy, of sort of how you teach people about the key parts of this story in some sort of way. I noticed that most with the notion of the scientist as rebel. Quote from Governor Perry in the last Republican election that got a lot of attention, where he said, "Well, I do not agree that the science is settled on this. The idea that we put America's economy at jeopardy based on science that's not settled yet, Galileo got outvoted for a spell, too," which obviously has a couple of problems with it since it was the church, not science. But the basic notion that really we have a sort of emotional attachment to the rebel in science and the person going against the norms, whereas something like the Intergovernmental Panel on Climate Change inherently doesn't seem very appealing to people. They don't understand why they should trust it, who these people are. And I'm just wondering if you have any ideas on how education can start to remedy that or other sort of major turns in the story in a way that just aren't covered.
Yeah, exactly. It's a great question. Actually, I thought about putting that Perry quote in, but I didn't because I knew I'd get an upset stomach and it was too early in the talk to risk that. There's so many things in that question, so let me just say two things. I mean, one thing that's really interesting is the whole idea of putting the economy in peril, right? So this is a classic contrarian, denier, skeptical kind of claim that if we do something about climate change, it'll cost us jobs. So it's fear-mongering about damage to the economy by addressing environmental issues. And of course, we know that that's not true either. There are lots of good studies now. We talk about this for the acid rain case and ozone. Those same threats were made about acid rain. If we control acid rain, electricity prices in the Midwest will skyrocket. That didn't happen. In fact, electricity prices came down as utilities were forced to upgrade their equipment, put in more efficient, better technology. So it's another example of making a claim that's really falsified by the evidence, but yet that doesn't stop people from saying it. The Galileo thing is just, it's hard to even know where to begin with that, right? Because that shoe is so on the other foot, right? Because climate scientists have been harassed. Climate scientists have had their emails stolen. They've received death threats. I've received death threats. It's the climate scientists who are going up against the established powers that be. So it's the climate scientists who are equivalent to Galileo. Galileo, as you said, was oppressed by the church, not by his fellow scientists. In fact, there's a great anecdote I love in the history of science. Kepler writes to Galileo. He's so excited about what Galileo has done. He totally gets that it's right. And he offers Galileo help. And he says, I'm working on this stuff that I think will, fix the Copernican system, because the Copernican system really didn't work. Well, Galileo doesn't want to have anything to do with Kepler because Kepler is completely crazy, and Galileo thinks with friends like that, I don't need enemies, right? So Kepler, with his Neoplatonism, is not going to help Galileo fight the Catholic Church. But in any event, but I think you're absolutely right. The crux of the issue, and we talk about this at the end of the book, is that we all have a very erroneous picture of science, and it's an erroneous picture that comes from focusing on historic episodes like the persecution of Galileo, or Darwin's struggle over trying to promote his theory of evolution by natural selection. And this is the ideal of the scientist as the rebel, who goes against the established view, and who does it as an individual, a heroic individual, unsupported by the institutional forces of science. This is completely erroneous, and it's erroneous on a couple of levels. It's erroneous when we talk about someone like Galileo because it's anachronistic. There really hardly is an institutional structure of science at that time. So Kepler tries to help Galileo. Some other people do too, but there isn't really the kind of organized scientific societies that we have today that even would have been available to support him. When we get to Darwin, at that time, by then there were organized scientific societies, and indeed, the organized scientific societies did defend Darwin. I mean, Darwin was notoriously terrible at defending himself. It made him sick to his stomach. He didn't want to go out. He wanted to stay home with, his wife Emma. So Huxley, takes up the cudgel, and so do lots of others. So the scientific community has, in fact, historically defended courageous scientists who have stood up against cultural or political pressure. So the whole story is just wrong historically. But it's also anachronistic because we live in a world now that's extremely different from the world of Galileo. And there may have been a time when a single individual like Galileo, although even Galileo, I mean, whenever you get into the history of these things, you always find they're much more complicated. There are many other people working. Galileo was not alone. Copernicus was not alone. But maybe they were more alone than contemporary scientists. But contemporary science is a deeply social, communitarian activity. And climate science in particular, if you think about the slide I showed a few moments ago with the temperature records, so that one graph represents the work of thousands of people who have analyzed literally millions of historic temperature records. No one individual could have done that work, even if they had dedicated an entire lifetime to it, even if they were a genius. The character and nature of modern science, the character and nature of questions like climate change, even just understanding the climate system, these are problems that can only be answered by integrating data, global data from around the globe. There's a wonderful new book about this by my colleague Paul Edwards called The Vast Machine, because he talks about the machinery, the infrastructure that has been necessary to produce the historic temperature records. So no one individual could possibly do that. So contemporary science is, in effect, a bureaucracy. And most of us have very hostile, especially Americans, because we're very individualistic and we like to glorify the individual. We have a hard time accepting that that's a good thing. And so if an individual comes along and says, well, I disagree, and I'm a rebel, and I'm courageous enough to stand up to the bureaucracy, well, that appeals to our sense of the heroic individual, and it appeals to what we think is what drives science forward. But it's a highly erroneous view. And so pedagogically, I think it is extremely important for us to teach the reality that science is a communitarian activity, and that actually its strength comes out of its communitarian nature, that it's the process of working together, of vetting of data, of internal criticism, hefty internal criticism within the scientific community. Scientists are not that nice. And if you go to scientific meetings, they're really mean to each other, So, I once asked Evelyn Fox Keller, the great theorist of women in science, why she thought there were so few women in physics. And I thought she was going to give me a great exposition on, some epistemic theory about the character of physicists. This is when I was in graduate school. And Evelyn says to me, because physicists are such bastards. So, scientists are really mean to each other. Geologists are a little nicer. But that meanness is actually important. It's part of the critical character of scientific inquiry. And so I think if we could do a better job of explaining that and explaining what actually goes into producing a graph like that, then I think that would help, at least for some of us, to understand. So if one person disagrees, well, yeah, they're entitled to their opinion, but it doesn't refute the work of the thousands who have gone before.
Mm-hmm. You answered, I had another question there of why physicists? Why, but I guess you just answered that question.
Well,
So
it's not because they're bastards, it's because of the Cold War. Of course it isn't just physicists either. These physicists, it's rooted in the Cold War experience, the anxiety about totalitarianism, which of course they shared with many other people, including Hannah Arendt. But it is important to point out that there's also a lot of climate scientists are themselves physicists, but they tend to be younger. They don't come out of that same Cold War history.
Well, and in a way, it's a very serious question in terms of what kind of evidence these physicists think are legitimate science and why. They have a clear emotional reaction against a lot of the kinds of science that go into climate science in terms of its standards of evidence and what's going on compared to, say, solid-state physics.
Yeah, but I think this is one of the important arguments we make in the book, that this is not about evidence. When we started the project, we thought, that was actually our working hypothesis, we thought that that's what this was going to be about, that this was going to be a conflict between different groups of experts who had different standards of evidence, and therefore evidence that was compelling to some scientists was not compelling to physicists who had different standards. And that, in a sense, was the story that I told in the book about continental drift. Because often when you see scientific debates, genuine scientific debates, that's what you see. You see different groups of experts who either value different kinds of evidence or have different standards of demonstration, or are persuaded by different kinds of arguments. Some people prefer mathematics, some people prefer empirical data, some people prefer site-specific evidence, some people prefer integrated global accounts. We thought that this was going to be something like that, and what we found very early on was that actually it was nothing like that. If you go into the archives, which we did, and you read William Nierenberg's letters, you read Robert Jastrow's letters, there is virtually no discussion about epistemic standards. This issue is not even on the table. What is on the table is this whole set of issues about the free market, about regulation, about how environmentalists are Luddites, and yes, they get extremely emotional, but not because they don't like the kind of data. It's because they think it's a hidden agenda. And that's really what's driving the emotionality and the passion of the story, not a kind of principled epistemic argument about different kinds of data. I mean, if it had been a principled epistemic argument, it would have been a much easier book to write, but then I wouldn't be here talking to you about it today.
Well, and less interesting, too, because then the way that public relations and the history of public relations plays
wouldn't
into
have
this
come into
wouldn't
it.
have come in, and
Right.
you wouldn't see how that's working.
Right.
I guess on the optimistic ending point of your argument, it had me thinking sort of what mechanisms might come into being to cause people to question or to come up with different ways of combining economic change with actual political change. And I think of something like World War I, where you basically have each country trying to experiment with how much to have a central economy, how much to have a free economy, how much to have command, how much to have rules, and that leading to very long-term changes in how they develop. And presumably with climate change, as we move 5 or 10 or 15 years forward, we're going to have ever larger problems and confrontations that will bring up new attempts to solve them. Do you see any mechanisms that might lead to sort of change in how people are formulating solutions?
Yeah. Well, I think it's difficult because one of the reasons that climate change skepticism and denial has been, had so much traction in the United States is because of the power of free market ideology here, which is much greater than in Europe or other places in the world. And certainly in Europe, people are much more comfortable with the idea of a mixed economy. In Europe, people are much more comfortable with the idea of socialism. I mean, sometimes when I give this story in Europe, people are sort of scratching their heads like, so why is it bad to be a watermelon, So, I think that this makes this problem in a way harder for us to deal with in the United States than it does in Europe. But on the other hand, the optimistic side is Americans have great faith in technology, more than Europeans do. So, and that's something that cuts across political affiliation in the United States. So one of the things about which there is agreement in opinion polls, and it's a staggeringly high level of agreement, I mean, it's a level of agreement you see about almost nothing else, is about renewable energy. 90% of Americans say they approve of renewable energy. Something like 90% of Americans say that they think wasting energy is a bad idea, so that's good. I mean, conserving and being conservative is a value that's shared by both conservatives and liberals. Wind power has the highest approval rating of any industry in America. It's like 95% of Americans think wind power is good. And there's an interesting little sub-story there. The gas industry is now launching a doubt-mongering campaign against wind power. If you see something in the paper that tells you that wind power kills birds, well, chances are it's actually funded by the oil and gas industry, just so you know. And if you're concerned about birds, come talk to me later. So I think that because we believe in technology in America, that's why I see this sort of small glimmer of hope there, that we don't have to agree about a lot of other things, but we could still agree that technological innovation focused on renewables and energy efficiency is probably a good idea, no matter what else you think about, whether Obama's a Kenyan or not.
Well, I guess it's also an interesting question in terms of how countries and regions start to brand themselves. I think of EU policy on technology, where basically they're interested in, say, having environmentally or physiologically clean technologies and having a reputation for that. So that if I buy baby products these days, when I'm looking for them, I'm like, oh, the French or German products have to pass these standards. Right. And I can imagine something similar starting to come into being, or I could imagine something similar with issues relating to global climate change.
Right, but it's trickier here because of
commons.
this, because we don't have that same thing. And also, I said there are several ironies in the story, and the other irony that I sometimes talk about that I thought about putting in here, but I was trying not to go on too long, but it's really appropriate thinking about Hannah Arendt and some of her concerns. I mean, one of the other ironies in the story is that the thing that these men who we studied were most worried about was the idea of losing personal liberty, right? This is what Fred Singer, when he says there's no limit to how much government can control our lives. And that's how they understood what they had done in the Cold War, that they had fought to protect American freedom, personal liberty. But the irony is that by delaying action on climate change, two things have happened. One is that we are now in a domain where some degree of disruptive climate change is essentially inevitable. We are going to be looking at increased likelihood of, for example, extreme weather events, flooding, hurricanes, things like this. I mean, many scientists think that's actually already underway, although there's some argument. I think that makes it more likely that the very intrusive government action, heavy-handed government action that they feared becomes actually more likely. I mean, when are we more likely to have the government kind of take over than in a national emergency, a national crisis? So I think they've actually increased the likelihood of the very thing they most wanted to avoid. The other irony is that if you ask who in the world is now moving ahead most briskly with solar power, do you know what the answer to that question is? And China. I'll tell you, it's not Scandinavia, right?
China.
It's China. China now leads the world in 5 different renewable energy sectors: solar, wind, efficiency, a whole bunch of things, biomass. So what message does that send the rest of the world? What message does it send to Africa or the rest of Asia if the liberal democracies are unable to solve this problem, but an authoritarian, former communist, I don't know what it is now, market authoritarian nation is the one that solves it.
I mean, it's part of why I brought up the branding question, actually, because I remember talking to a Chinese scientist who essentially said just that, sort of, we're solving this problem and you're not, or you're not even addressing it.
No, the Chinese
and that's something
right
that,
now, right.
They literally were sort of looking down on us, that you don't have a mechanism for even coming up with a problem, whereas we have a government with a lot of scientists in it and an authoritative central structure that seems useful in that regard.
I was at a meeting in Switzerland, the Swiss Climate Forum, which was mostly a meeting of business leaders and talking about technical innovation, and there was a talk from a Chinese businessman about the Chinese solar city. This is a city that's being built in China, entirely powered by solar energy, mostly solar thermal, by the way, which gets very little discussion in the United States, but is probably much more efficient than solar photovoltaics. And basically what he said, it was a kind of Khrushchev-type moment, He basically said, we're going to bury you. I mean, he didn't say it quite that boldly, but, it was virtually, we're going to sell you the rope that you'll hang yourself with, And that was kind of sad to me. I mean, interesting to be witnessing that, but also sad because, as you said, they're not just talking about it in China, and they're certainly not arguing about the science. They're actually moving ahead and building prototype cities. And of course, the whole point of that is then to sell that technology to the rest of the world, generate jobs, improve their balance of trade, all things that we say we want to do here in the United States, things that both Democrats and Republicans would claim they agree about, and yet we aren't doing it.
Maybe we should open up to questions from the audience. I see somebody in the way back whose hand went up.
Went shooting up.
Yeah.
Engaged in action are the scientists, but at the same time she's very critical of the role of the scientist as being the leading political actors. And in some ways I think that your presentation at the end kind of begs the question of why we should necessarily side with one group of scientists, the climate change ones, versus the other. I think it's important to say that in fact there is an agenda on both sides, and that's where the debate has to take place, not just in terms of who's got the right evidence, because some people can in fact say, even if it's the case that climate change indicates that we're going to be suffering increasing disasters, why should I care?
Okay, yeah, well, so there's a lot of different things in there. So I think one thing that's important to clarify is that it's not, in my view, it's not a question of which scientists do we believe. The vast, vast majority of scientists who actually work on climate change, which is thousands of scientists around the world, are all in agreement that climate change is underway. So what you had was this tiny handful of people, and it really was tiny. I mean, we focused on 4 people. There's about 5 more that we could have put in the book. Absolutely tiny group of people, but who became very influential because they had access to power, they had access to money, and then because they connected with this larger world of think tanks and conservative foundations, and then did begin to get money from the fossil fuel industry, which I didn't talk about today. They were not climate scientists. They never actually worked on climate science. They never collected a piece of original data. So this gets back to the education question. You have to ask, who's actually doing the work here? Who are the genuine experts? And that's where the question of expertise becomes important as well. There are genuine experts, and then there are serial contrarians, So it is really important to ask questions about who are the people who are making these claims. And this is where, we heard earlier about the issue of the media and gatekeeping. It's true there are no gatekeepers in the blogosphere, but one of the things we say in the book is that if we believe that traditional media serve as gatekeepers, then we'd have to say when it comes to science that they failed at that role, because what we show in the book is that even very respected media outlets, people that we would consider the prestige press, never asked the question, who were these people? Are they actually experts? And so prestige media consistently quoted people like Fred Singer or Bob Jastrow or Fred Seitz on par with the thousands of climate scientists, as if these were equal. And that contributed to the impression by the American people that this was an actual scientific debate. So I think it's really, really important to make that point clear. Now, to bring it back to Arendt, I think, I agree. I think her position with respect to experts and truth tellers is problematic, because one of the things she argues is that for truth tellers to maintain their credibility, they have to be outsiders. They can't really be engaged. And I think that's problematic on several levels. I think it's problematic, first of all, because I think it actually buys into the idea of the scientist as the kind of isolated, Descartes in his room watching them, the wax melt, right? It's just not how modern science operates. No one can be a scientist in isolation in the modern world. That's simply not possible to do. And any scientist who puts himself forward and says, well, I'm a rebel, you should believe me because I'm a rebel, I think we should view that as highly suspicious. And there's many examples we can think of. Because a real scientist has to work with other people. Now, it doesn't mean they can't be intellectually independent, but if they claim that they're a rebel, to me that's like there's something suspicious going on there. So, and then if you are genuinely an outsider, it seems to me there's a bit of a paradox there, right? So Arendt is saying that to be a truth teller, you on some level have to separate yourself from society. But in order to engage with society, to tell the truth, you have to engage. And you can't get access in our contemporary world. I've experienced this myself this year. I thought, naively, that I could write a book, and that if it was a good book, people would read it, and it would have influence, and that might maybe shift the debate a little tiny bit. But what I learned was, no, I couldn't just stay home and go to work on the next book. I had to go out in public. I had to, promote the work. I had to blog. I had to write opinion pieces. I had to come to events like this. I had to go on TV and the radio. It's really exhausting, and it's actually, no, it is. Not to offend you. It's great to be here, but it's exhausting. I'm at the end of a year and a half of this, and it's really, really exhausting. It takes you away from your family, it takes you away from your friends, and it takes you away from your work. So, there is a conflict between trying to tell the truth as you see it, trying to be engaged with people. You all have come here, which is great. It means you're interested, and that's terrific. But by being here with you, I'm in a sense violating what Arendt said about remaining an outsider and just doing the work. So I think it's a very problematic thing. And then I think it's doubly problematic for scientists. I'm a historian now. Historians are supposed to be interested in culture and politics, so that's okay. I'm not violating anything in my discipline, so I'm not offending my colleagues by being here. Quite the contrary. My colleagues think it's great that I'm invited to the Hannah Arendt Center. That's good. But now if you're a scientist, right? Scientists are supposed to not be interested in politics or culture. They're supposed to do something that is, in a way, protected and isolated from political influence. And most scientists desperately want that. Most scientists desperately want to be able to do science in a kind of insulated way, to be able to cultivate norms and ideals of objectivity, practices of objectivity that enable them to look at complex data sets and to say, what is really going on here? And to allow for the possibility that what is going on is not what they would want it to be. And for me, when I was doing my work on plate tectonics, I thought this was the most powerful and moving part of the story of plate tectonics, was scientists who had data that they didn't like, data that told them stuff that went against everything they'd been taught in school, data that went against what the director of their own institute believed, data that they didn't like. And the most wonderful story is this story I have in the book about a geophysicist who was at Columbia, Xavier Le Pichon, who wrote his PhD thesis explaining why plate tectonics was impossible based on heat flow considerations. And then he goes to a scientific meeting and he hears a presentation about plate tectonics. He goes home and he says to his wife, pour me a stiff drink. Everything I've written in my dissertation is wrong. Okay, so that's a really courageous moment, right? And then the next day he starts work, and he does work that essentially rejects everything he's done up until that time. And he writes a paper that becomes one of the most cited papers in the history of earth science. So that capacity, that willingness to look data in the eye and admit that what you thought before was wrong is, to me, the most emotionally compelling thing about science. But it's very hard to do that if you're deeply engaged in political and social discussions. So there is a way in which scientists, rightly in my opinion, try to isolate themselves from the buffeting of popular culture. But at the same time, if they isolate themselves completely, then the work they do is of no use to them. Somebody's got to make that connection back to the rest of us. And so then the question partly becomes, well, whose job is it to do that? And virtually every scientist that I know has said to me that he or she thought that it wasn't his or her job to make that connection back to the rest of the world, that it was the job of journalists. Okay, well, we have seen that that hasn't worked. Okay, so now we have this problem. Journalists have, for whatever reasons, been unable to do it. The blogosphere, as we just heard, is now proliferating with weird theories and who knows whatever else. So whose job is it to make that connection? And I think that's a very profound question, and I don't think that we have a good answer for that yet.
Maybe one last question. Yeah, Tabitha.
I guess my question is related to a quick anecdote. The anecdote is this. I was having pizza at Salvatore Pizza, which is in Red Hook. This was maybe 2 years ago, maybe a little more. And a couple of people who work there and some other people sitting at the bar. I was by myself. They start telling me about, this is a discussion of climate change. It's a, liberal conspiracy. And anyway, long conversation. And towards the end of it, one of the women was studying environmental science. And the conclusion of the discussion was a little bit of proselytizing, I think. And the upshot was the Earth isn't going to disappear because of climate change, but people might. And they were okay with that. Or maybe not okay with it, but it was just understood that that's like, part of,
Like we'll go the way of the dinosaurs.
Right. Well, but I don't think it's the dice. What I took away from that, and I could be wrong, and I guess this is where my question is I thought it was a bit of millenarianism. And I wondered to what extent not only the Cold War, but also shifts in American Christian fundamentalism have an impact on even the conspiracy, even the famous four. Yeah. Does any of this have any play? And I'm not only thinking about George W. Bush, but I'm thinking more broadly about why so many people are willing to take a chance on their children and grandchildren's lives.
Yeah, well, there is millenarianism here, and this is a really complicated thing, and I'm not good at giving you short answers to complicated questions. But let me just say a couple of things. First of all, I do think a lot of people do actually misrepresent the problem. The planet is not going to disappear. The planet's going to be just fine, and I don't believe people are going to disappear either. We don't have any evidence that climate change will wipe out the human race. What we do have evidence is that climate change is going to be costly and disruptive and cause suffering. And we have plenty of evidence that the people who suffer the most will almost surely be the people who always suffer the most, which are poor people who don't have highly developed adaptive capacities. Although not only poor people, it will also include rich people with coastal property on Cape Cod. So, including the Bushes, I need to point out, and the Kennedys and a whole lot of other pretty rich people. So this is really about social and economic disruption. And hurricanes, for example, cause tens and hundreds of billions of dollars in damage, right? So this is about having to spend a lot of money to fix a problem that we could have spent less money on if we'd fixed it sooner. It is about destruction of coastal property, cultural values, and it will be about deaths. I mean, hurricanes and floods kill people. So we're talking about suffering. We're talking about human suffering, and I think we haven't done a good enough job of explaining that suffering is here and now. Climate change is underway, and I think scientists have been part of the problem because they always talk about climate change in the future. They always talk about what's going to happen, and they talk at great length about children and grandchildren. I contributed to a book that has children and grandchildren in the title, and I argued with the editors, and I said, it's a really bad title. You're perpetuating the idea that this is something that's in the future as opposed to something that's going on right now. I didn't win that argument. So, oh well, I win a lot of arguments, but I lost that one. So I do think it's important to recognize this is a here and now problem, not a long ago and far away kind of problem. And then in terms of the millenarianism in general, the whole issue of religious responses is very complicated, and I have a graduate student working on this right now, so I hope in a year or two he'll have some results to publish. But most of the opinion polls, a lot of people have blamed some degree of this denial that we're in on evangelical Christian thinking, and the evidence we have so far actually does not support that. It shows that actually the biggest controlling variables for being skeptical or in denial about climate change are being male. I'm sorry to say it, but it's true. The number one correlation is with being male, with being white, and being old, like over 50. That's not so old. Okay, being middle-aged. So that's kind of interesting, right? And that tells me, I think, that the denial is actually, it's about what we stand to lose, right? That a lot of us don't want to admit this is true because it's a bad news story. It's about a problem. And Americans, in a sense, have the most to lose because we have the most energy-consumptive lifestyle. And it's also being wealthy and educated. Wealthy, educated white men have the most to lose because they're the ones who benefit the most from the status quo and business as usual. So one of the surprising facts, a lot of times people claim that people of color don't care about environmental issues. That turns out to be untrue. And in California, during the most recent election campaign, there were a lot of detailed polling done about our climate change law, AB 32. Black, Hispanic, and Asian American communities strongly support AB 32. And I think that part of the reason is that they get it, that pollution is not in their interest, that environmental damage hurts their communities, but it's the wealthy white people in Orange County who think that they won't be affected by this, that they think that they can adapt, they can turn up their air conditioner, whatever it is.
We should probably pause there. Thank you very much, Professor Oreskes.
Thank you.
Thank you.